Okay, so welcome to week 9, and we're moving right along. And I do want to mention again, I want to applaud you all. Good job. And get a reaction from my part. So, good job on the midterm. You probably stressed out, but as I said, overall, the class did very well. The average was just above 90%. So, you all should be happy with yourselves and be excited and motivated to continue. So the first thing I'd like to ask, are there any specific questions? Because I didn't really find any. There's a couple of the questions that were questionable, but I didn't really find anything substantial across the board. Kind of the first time I've been teaching this. This is my 4th year. That there was not one question that everyone struggled with. As a matter of fact, we had one student that got all the questions correct. That's another first. So are there any questions about the midterm? I know you all just want to move ahead and not worry about any tests. So yes, you don't have a major test until the final. I know you're all looking for that. But once again, thank you all. Good job. And I really appreciate the hard work. And so keep it up. No slacking off now. That's the key. All right. So we're moving into, where are we going? We're moving into Module 9 and learn all about subqueries, queries that really depend on other queries. Subqueries, I can tell you in my database administrative career, probably joins and subqueries and some other things like routines and functions were I use those the most. So subqueries, it can be confusing, so prepare yourself, but they're very, very useful. All right, so our first topic in this module is fundamentals of subqueries, and our objectives to find and explain the purpose for retrieving data, still retrieving data, construct and execute a single role subquery in the where clause. Yes, it's actually included in the where clause, and then distinguish between single role and multiple role or multi-role subqueries. There's a distinct difference. All right, so as usual, we have to define why we need to know about subqueries. So as a friend asks you to go out to a movie, but before you could answer yes or no, you have to first, well, I don't know. I mean, this is probably written for high schoolers maybe. I don't think any of you have to check with your parents before you go to the movie. We're all consenting adults, right? So as someone ask you to answer a math problem, but before you can give them an answer, you have to do the problem yourself. This is actually a big deal being an instructor. Some of my colleagues forget that they have to know the information before they can ask students to perform a task. So yes. So there's things here, you're kind of getting the theme here. Asking parents or doing the math problem are examples of subqueries. In SQL, a subquery enables you to find the information you need so that you can get the information you want. And so there you go. That's the human interpretation of a subquery. And you'll see here how useful subqueries can be when you're tasked to create a specific report and you don't have all the parameters, etc. But this is usually where we lean on subqueries. So the subquery executes to find the information you don't know. That's usually the case. The outer query, which is the kind of the first query you see, uses that information to find out what you need to know. All right, that's kind of a tongue twister, but that's how subqueries work. So being able to combine two queries into one can be very useful. As I said before, when you need to select rows from tables, but a condition that depends on the data in the table itself. Yeah, and that's a high-level narrative to try and essentially figure out why you would need a subquery. So, an overview: the subquery is a select statement usually. It's usually you're selecting something from the data that you know that's embedded in a clause of another select statement. So it's a select statement that's embedded. So, and you'll see here when we come to the examples. So a subquery executes, yeah, you see one word that I have trouble getting out sometimes, execute once before the main query. I will give you a kind of a heads up or a hint. When you're writing subqueries, make sure before you put the query together, that inner query, make sure you can run that. And then in SQL Developer, you can actually highlight the inner query and run it. Usually the biggest problem with subqueries is that you're expecting a specific result from the inner query and you don't receive it, or the outer query does something different than what you're expecting. So a recommendation, a hint, to lessen the amount of angst that you may run into, just kind of a hint, make sure that inner query or the actual subquery can run independently. So the result of subquery is used by the main or outer query. So, which is essentially why you want to make sure that there's results, that the results match your expectation. So subqueries can be placed in a number of places within a SQL clause, including the where, the having, and the from clause even. Yes, you can throw a subquery in there as well. All right, moving on along. So here's the general syntax. You see here, select, and you have a list, from a table where, and then you have your expression in the where something is equal to or greater than or whatever. And then you add your subquery to that. Take a note of this. The subquery should be surrounded in this version of SQL by parentheses. And some database management systems, you don't need the parentheses. With Oracle, please remember that. Yeah, you want to surround it by parentheses. And it helps you to understand. And essentially, if you want to run the subquery, and we'll run a couple of examples of that, but that is the general syntax, right? It's a subquery. All right, so some guidelines. I always have guidelines. Enclosed in parentheses, I just stated that. Generally, it's a subquery is placed on the right side of a comparison. So you have an entity or a column is equal to or greater than the subquery. General guideline is placed on the right of that comparison. The outer and inner queries can get data from different tables. Yeah. Only one order by is allowed in the subquery, and it should be the last. As you know, the order by is always the last clause in your select statement, and it's usually associated with the outer query. Remember that. The subquery cannot have its own order by. So remember this, you can't put an order by in the inner query. It will not run, you get an error, and you'll be frustrated. So as far as the number of subqueries, generally, the buffer size is actually relatively large, but you have to be very careful with the logic because there's other ways to run some of these queries without having a subquery within a subquery within a subquery. I think the most I've done as far as the layers or the levels is just like 3. And I was a database administrator a long time. Of course, you have things like joins and other functions that you can run, but subquery can become very confusing very quickly. So please remember that. All right, so let's go right into I'll pause. Are there any questions so far about subqueries? Subqueries can be fun, so put your fun hat on. So yeah, this is gonna be fun. All right, so there are 2 types. There's a single row subquery, and that uses a single row operator, greater than equal to, etc. And in turn, only one row from the inner query. Now, hopefully that makes sense. And you'll see what I mean very soon about the inner and the outer, how those are placed. Generally, the inner queries within the parentheses and etc. All right, then you have a multiple row subquery that uses multiple row operators like in, any, and all. And we went over those a long time ago. So I will refresh your memory on those. Remember, the N is usually, and the NE is usually a listing, a group, something that you can have multiple conditions or multiple returns. So that's the whole idea of a multi-role, hence the name subquery, right? All right, so let's go to some examples. I know this is what you've been waiting for. You're probably thinking, yeah, this is a lot of good information, but can you just show us how to do it? All right, yes, the answer is yes. So what if you wanted to find out the names of the employees that were hired after Peter Vargas? And one thing I do want to mention, side note, all of these individuals in our little employees database they were actually Oracle employees back in the day. So I think King is actually still around, possibly. I don't know. Anyway, that's a side note. That's a tangent. Pay no attention to the man behind the curtain. So the first thing you need to know, yeah, if you remember that question, is the answer to the question, when was Peter Vargas hired? So once you know his hire date, then you can select those employees whose hire date are after. So, and you don't have to guess, you guessed it, you can accomplish that with the subquery. And please take a look at this. This example, we have select first name, last name, hire date from employees where hire date, and our little subquery, which is going to be a date, right? Select hire date from employees where last name is equal to Vargas. So you see that the only thing that's going to be returned from that is a single date, right? Does everyone see that? Thumbs up, please. I have to always check to make sure we're all still awake. You all see that, how that subquery is going to work. So there will be a date there, and then your result will be all these particular employees. Zlotky, Grant, Morgos, and Lawrence, all after. And if you wanted to see what that response was, and generally I will do that, especially if it's a more complicated query, we want to make sure the result of the inner query. And I'm going to say this a lot because it's always a problem that we run into as far as expected results. All right. So, and then some things to pay attention to. So if the subquery returns a null value or no rows, then obviously you'll get no response. You get no data. Of course, your system won't tell you no data. You just get this blank screen, and you'll have a blank stare, and you'll say, what's going on? My query looks right. This is another one of those situations where if you're receiving no results, run that inner query, because that will tell you why. It'll definitely help you understand what's happening. All right. So there you go. In a nutshell, those are the fundamentals of a subquery. So say that topic was pretty rapid, pretty easy. I think I slimmed that down quite a bit to make sure it makes sense. Our terminology, subquery, inner query, outer query. Now I do want to point out before I move ahead, do we all understand which of these, and maybe I should label these, which of these will be considered the inner query and which is the outer query? So just to make a note, select hire date. This little query here is your inner query. And in the order of operations, this will essentially run first. And the result of that will help in this outer query, and this query out here is the outer query. So I'm harping on that, but sometimes if these queries get a little complicated, you need to know what's happening, et cetera, et cetera. So inner query, outer query, subquery, and then single row. And we haven't really started multi-row. Multiple row. We're going to get into that now. Okay. All right. Oh, and that's our summary of what we just learned. Even though we didn't really start with multi-row, we will get to multi-row queries. So please don't worry. Even though that's included in the terminology, you'll see what I mean by a multi-row query. So if I'm confusing you a little bit, that's on purpose. No, it's not really. All right. Let's go into, whoops, I forgot to change that. Oh, no, that's right. Hold on a second. I think I did something wrong here. Yeah, this should be 9. All right. I confused myself a little bit there, so please bear with me while I make my mistakes or I make sure that you aren't confused by my mistakes. So, all right, so we're in module 9. So just to offer an explanation, during the spring, which of course I copied the courses, there's always an extra week because we have spring break, so it throws everything off. So anyway, that's my explanation. All right, so now we're going to dig in a little bit deeper into single row subqueries, that specific type of subquery. And these are objectives. Construct and execute a single row subquery in the where clause or having clause. And remember, having clause is usually associated with group functions. So don't forget about what you've learned. This course is pretty much cumulative, so please try not to do a brain dump, especially after midterm. You're like, yeah, I don't even know any of that. SQL does build on itself quite handily. All right, construct and execute a select statement using more than one subquery. Ooh, daunting task, but not too bad. And then construct and execute a select statement using a group function. Oh, you thought you're going to forget about group functions. You know, those whole, summing and averaging and all that fun stuff. So as you probably realize, subqueries are a lot like internet search engines. I suppose so. I suppose you can say that in some way. They're like search engines. They're great at locating the information needed to accomplish another task. So in this lesson, we're going to learn how to create even more complicated, and that's a relatively subjective statement. Complicated. You're getting, I'm pretty sure you're getting more accustomed to putting these queries together so that they're not so complicated. But do keep in mind, subqueries, they do save time, and it is something that you'll use a lot of. Okay. Someone just came in. Who just joined the class? I saw my little screen move. Is that Dylan? Hello, Dylan. Thank you for joining. All right, let me check the chat. Okay, that was Dylan. All right, glad you made it. We're digging into subqueries. Okay, all right. So, all right, let's move ahead. So, facts about single row subqueries. They return only one row. They use the comparison operators that we're normally accustomed to as far as single comparison operators as far as single row, equal, greater than, equal to, etc. They always enclose you do enclose them. This will hold true for all subqueries, enclosed in parentheses. That is a required syntactical part of Oracle. And place the subquery to the right-hand side of your comparison condition. So that, as long as you follow those simple rules, in fact, you're fine with subqueries. So you can use different tables. We said this before. Once again, order by only in the outer query, as order by should only be, there should always only be one order by. And the only limit to the number of subqueries is buffer size, which in these new engines, the buffer sizes are quite large, but it's more, I guess, associated with the logic of what you're trying to return. And remember that. I mean, limitations, well, remember, the technology here is, upwards of this new Oracle, probably 40 years now. So our computing resources are quite higher than they were when I was working on databases, when we were limited to, kilobytes and just at some point megabytes. But anyway, all right. So the outer and inner queries can get data from different tables. So who works in the marketing department? And this, basically, we're going to use different tables, the department table and the employees table. And don't think that this is the only way that you can satisfy this question. This is another. And I've had some of you actually use subqueries already in place of joins or in other types of queries. But if you look at this query, basically we're pulling in the department, basically the marketing department, right? So select last name, job ID, department ID from employees where department ID is equal to, and then we're using the departments table in our subquery. So it's kind of like a join without doing a join. You're just running a subquery. And you see here, I'm showing you the results of the inner query. So what's going to return in this whole query is going to be the number 20 or department ID 20. So now we know that Harstein and Fay works in the marketing department. Woohoo. Right. Queries from different tables. More than one subquery can return information to the outer query. So basically, this should have been two. I should change that title. Boy, I did some. So this is actually more than one query, subquery, running off of an outer query. So if you look through this, sorry if hopefully I'm not confusing you too much. Select last name, job ID, salary, department ID from employees where job ID is equal to, and we want to know basically all the individuals that are job clerks, right? And what department they're in. So we're using a where and then our comparison and inclusive connector to ensure that we get all the information that we want in this report. So we want all the clerks and we want to know their department ID. So, and of course we need to know their salary. So that's a interesting example. Once again, I'm showing you the result of the subquery or the inner query. The job ID is going to be store clerks and the department is going to be 50, and that matches what our results. So yes, you can run a subquery on any component. Well, these are all in the where clause, but this is a combined using two subqueries. That should have been two subqueries. I need to change that. All right, I will change that. All right, so group functions and subqueries. Yes, group functions can be a part of your subquery experience. A group function without a group by clause returns a single row. And if you remember way back in that group, the group by and group functions, once again, be very careful with the logic within your query. And yes, I'm teaching you subqueries, but sometimes a subquery may not be appropriate. So it really depends on how you want to answer some of these questions. So the query in the next slide answers this question: which employees earn less than the average salary? And so that's actually a pretty good usage of a subquery, because what we can do is use the group function average. And so our inner query is select the average salary of our employees, which is going to be 8,775. And we want to know who earns less. So our comparison operator is less, and it's salary. Select last name, salary from employees where salary is less than the average. There you go. Now, so because this is a group function, we'll get one number here, right? That's probably the most efficient way to do that. And so now this verifies that all of these employees make less than the average. They all deserve a raise. They've been working for too long. So out of our 20 employees, 12 of them, or however the result is, make less. Yeah, 12. All right. Does that make sense to everyone? Thumbs up, please. All right. Keep you all on your toes. Yay. Okay. All right. So remember, we had this thing called having clause that you had to use in place of a where clause. So remember, the having clause is similar to the where clause, except the having clause is used to restrict groups, right? As opposed to single big filtering scenarios. So it's always included with the group functions such as min, max, and yeah. So always associate having with group functions. And yes, you can use a subquery that's a part of a having clause. So which departments have the lowest salary that is greater than the lowest salary? Yeah, tongue twisters on questions in Department 50. So in this example, the subquery selects and returns the lowest salary in Department 50. So within the subquery, select minimum salary, group function. So it's going to bring in the lowest in department 50, which is 2,500. And we want to know which departments have the lowest salary that is greater than that 2,500. And you see here all of these departments, 110, 90, 10, the null department or the non-department, 20, 60, and 80 all have lower salaries that is higher. What was the question again? The lowest salary that is greater than the lowest salary of department 50. Yeah. So this may be something that someone wants to know. So this is how you would form that query. Okay. Min salary, all group functions. Having, remember, filtering out groups, use that having clause. All right. All right. So in this one, basically the terminology is still the same. We just went over single role functions and essentially how we can use more than one subquery. That was that second one. And then essentially using group functions. Now, please make a note that subqueries do not go outside of the general rules that you've learned about, single queries. Remember, you're just embedding a query within a query. So please don't forget about the structure and the syntax and all that. That's usually a trip-up point. All right. And now you've been waiting for this multi-role. This is, what is that? How do we run that? So we're going to get into that. That's topic. Hold on. I didn't do my due diligence. All right. This should be module 9, not 10. All right. All right, 9.3. Yay. I probably didn't change the fourth one either. So anyway, on to multiple role or multi-role subqueries. Correctly use the comparison operators in, any, and all. And yes, we've seen these before and you've probably forgotten, but I'm pretty sure we have. But anyway, well, you'll see how they work. Construct and execute a multiple role subquery in the where clause or having clause. Describe what happens if a multiple row or multi-row subquery returns a null value. And you can probably guess that. Understand when multiple row subqueries should be used, when it's safe to use a single row subquery. And I'll give you a general rule of thumb. Most of the time, you're going to be running a single row subquery because you're looking for a single value, not multiple values. Most of the time. I mean, I say generally about 90% of the time I was running a single row. Multiple role subqueries are usually not that effective or efficient, so we'll see. We'll see what. Pairwise and non-pairwise, and I'll expand the definition of those. And basically, it's another way to offer some levels of confusion, but we'll talk about pairwise and non-pairwise, and then exist and not exist. Just another way to test that inner query. You can simply, believe me, in very complex database systems, if you can run a way to test the subqueries before you actually put them into play to create a report, it's always a useful thing. So that's the purpose of exists and not exists operators. All right. So basically, once again, subquery is used to find information using something okay, I'll read it. Designed to find information you don't know so that you can find information you want to know. There you go. So single row subqueries can return only one row. What if you need to find information based on several rows and several values? And believe me, it's, that may materialize to be a purpose, but it's used less, I'll just say. So a subquery will return several rows. This is a multi-row subquery, and they use multi-row comparisons in any and all. And I'll show you what that means. So here, take a look at this query. So the question was, whose salary is equal to the salary of an employee in Department 20? It's pretty vague. So this example returns an error because more than one employee exists in Department 20. So yes, you can't run a single role subquery, and that's the error you get. Subquery returns more than one rows. more than one row. So you're trying to run, because we're using salary equal. So this is the bad example. Thumbs down. Do not run a single row subquery if it's going to return more than one row. Logically, you should be able to read through the question and figure out exactly what the response should be. And that's the explanation there. So what we're looking to as far as multiple row or multi-row subqueries, we're looking to process those multiple values. So the comparison operators, we don't use the equal and less than. We always use an n, any, and all, because that gives the query the opportunity to return more than one row. And a not operator can be used with any of these three operators. So not in, not any, not all. Now, sometimes that can be a little bit confusing. They're just like not equal to. Basically, you don't want something, but you want everything else. So I know I'm kind of rambling, but that's what the not operator is used for. Diana?
Yeah, so I was wondering if you don't know how many results will come back, are you just safe like always using the multiple row operators instead of the single row?
If you don't know how many, well, okay, that's kind of a trick question. Generally, when you're running a subquery, you're using the single row because you know there's only one. Generally, you know there's only one result. But you're right. If you're not sure, use a multi-row, because that'll return, even if it returns a single row, that will not give you an error. So,
Okay, thanks.
yeah, you're welcome. Thank you. Good question. All right, let's look at some of these operators. So the and operator is used within the outer query where clause to select only those rows which are in this particular list of values. So if you look at this example, select last name, hire date, and we're basically extracting it. Remember the extract function. We're looking at a year. Basically, we're extracting a year, hire date from employees where department ID is equal 90. So what's our purpose here? So we are interested in all employees that were hired the same year as an employee in Department 90. So that's an odd question, but we're comparing just the year, which is why we're using the extract function. So in all employees in this list that match, who've been hired the same year as employee in Department 90. That's a very odd way. So King and Whalen were hired the same year, etc. So you know that these are all the employees in Department 90. We would need to know, why would we need to know that particular scenario? But that query is a little confusing, but remember, in represents a list. So that where this year, this hire date year, that's all this first part is referring to, is in this hire date year. So does that make sense to everyone? Can you read through that query and understand what we're trying to accomplish? If not, please ask. Or you can give me a thumbs down too, if it's not a query that makes sense to you. Remember, the N represents a multi-row, and we just have, and this is where your subquery is here. Yes, no, I'm getting no response. Oh, Brendan says he understands it. No one else? Should we pause to see what this produces? Trevor says no problem. Justin's got it. That is true. Trevor says in the chat, for a few of these, it's usually figuring out or interpreting the question and not actually coming up with the query. That is, in my experience, that's usually the case, and you have to interpret or misinterpret accordingly and see the look on your boss's face or your colleague's face or your coworker's face when you produce the right answer and they have no idea how you did it. So, yeah. All right, let's move ahead. So here's the explanation. The inner query will return a list of years that employees in the department were hired. The outer query will then return any employees that employee that was hired that same year as any of the inner. Yeah, that's kind of a dumb question, but I'll admit. And so if we further expand that to the any operator, so this is used when we want the outer query where clause to select the rows which match the criteria less than, greater than, equal to, can be used, or at least one value in the subquery result set. So this one is interesting. So this example showing will return any employees whose hired year or year hired is less than at least 1 year hired of employees in Department 90. So take the time to read through this query, select last name, where the year, remember the extract, all that where extract is just looking at the year, the less than any. So remember, it's looking for anyone in that list that is returned that matches the criteria. So once again, it's like, what question are we answering? And why do we need to answer it this way? But that's where I'm saying these multi-row functions are odd in the way that you're creating a response to the question. I would run this completely different, but this is a representation of the subquery, and that's fine. But don't let it confuse you. Remember, any, and you do have, and I'm going to offer an explanation to that here in a minute. Usually in is a better usage. Any could run into problems because you may not, the result may be a little bit different than you expect. And all is even worse because all, basically, if it doesn't match everything, then you usually get no result. So all operators use when you want the outer query to select rows which match the criteria of your single row operator of all the values. So it has to match exactly. And usually this, unless you specifically know what's in the data, will return no results. And you see here, I am representing the inner query. It's returning all these years hired. You're asking who are the employees that were hired? Who are all the employees that were hired in these years? And of course, all do not match, right? So this is why we get no data. Because there are some employees hired outside of these years. And remember, and that's the difference between any. This will return any that matches this year. This, you need to have all match or else you get no data. Does that make sense, everyone? Can we grasp that concept? I always hesitate to offer this because it can be very confusing, especially, and then you have to decide which of these multi-row operators you need to use to ensure that your result is accurate. All right, I got a lot of thumbs up. That's good. Now, null values, null values are always a problem. The best way is to handle them before you try and run a query, but suppose that one of the values returned by a multi-row subquery is a null, but others values are not. So it won't affect the in, because null, if in or any are used, the autoquery will return rows which match the non-null. So basically, the null won't impact if you use in or any. This is what I'm illustrating here. Even if there is null, it's just going to match the returns that have values. The problem with that, if you use null as with all, is a very difficult one to match because it returns. For the most part, unless everything matches, then it returns null. No results. Now, if you use all and there's null values returned, then that absolutely makes everything null and void, essentially. So you'll get no results. So that just means be very careful using the all. That's the one that will drive you nuts because all represents everything. You want to get a one-to-one match or everything that matches the criteria. So that's null values can drive you crazy. I would suggest always handle those nulls first. Do an NVL or an NVL2 or whatever you need, or at least make sure it's not going to impact your results. All right. Group by and having, and this is still in our multi-row queries. So as you might suspect, the group by clause and having clause can also be used with multiple row subqueries. What if we wanted to find the departments whose minimum salary is less than the salary of any employees who works in department? These are, Oracle is so ridiculous, but these are interesting questions. So this would be the results we're looking for. So we need a multi-row subquery which returns the salaries of employees in department 10 and 20. The outer query will use a group function min, so we need to group the outer query by department ID, right? So this is what this query will look like. So when I'm highlighting the inner query, here select salary from employees where department ID is in, multi-row 10, 10, and 20, and you get these salaries. And then we want to select the department ID minimum salary from employees group by department ID, having a minimum salary less than any, less than these. So you see that these are all less than it's 4,400, 13, and 6,000. But because we use any, so once again, why would we run a report like this? And are we solidifying any discrete information? So this is an example of basically something that you can probably form into some type of result to satisfy some requirement. So, but that's just using a multi-row function with a group function. Okay. All right. All right. You can do multiple column subqueries. Subqueries can use one or more columns. If they use more than one column, they're called multi-column subqueries. Ooh, look at that. Multiple column subqueries can be either, and this is where the pairwise, non-pairwise. When you use more than one column, pairwise, and give you just kind of a very basic definition. It means that your inner and outer query columns are exactly the same. That's what's known as pairwise. Here we have employee ID, manager ID, department ID, and where manager ID and department ID in manager ID and department ID. Now, do you need to run a query like this? And if you read through this query, it's very confusing, but we're trying to represent the idea of pairwise, and pairwise just means that columns are basically paired. And we're running something pretty odd here because our inner query is just selecting manager ID, department ID from employees where employees ID are in this these employees 149 and 174, right? So that's what our inner query is, and we want to pair that with employee ID, manager ID, department ID from employees where the manager ID and department ID is in that group. And employee ID is not in. So why? Well, when we want managers, what question are we answering with this query? I was trying to figure that out, but it is basically an example of a pairwise, which means the columns, if you're using multiple columns. So does that, okay, let me ask you all this to keep you engaged. Now, does this query make sense? Well, not the result of it, but how it, what the information as far as the result, can you read through this and understand how you got these results? I guess that's my general question. Go ahead, Diana.
I was wondering, so when the inner query, it returns basically a manager ID and department ID for these two particular employees. And then when you get to the outer one, so the computer like automatically knows, or like SQL automatically knows to match the manager ID and department ID to the ones returned out. Like it knows.
Right.
Okay.
Because we're looking in the where clause, we're looking for manager ID, department ID, and hence the pairwise.
And this works because it's the same column names from the same table, or just the same column names?
Same column names.
Okay, so if you had a different table with the same column names, it'll still know to match it up.
Yes.
Okay, thanks.
Is it useful? Yeah. Possibly. Usually there is some order and some consistency to how you build these tables, and you don't have to worry about pairwise or non-pairwise, and even in a subquery. But that's another, part of stability we're going to call. But yes. So to offer an explanation, so first the subquery retrieved the manager ID, right, and department ID values for employees with employee ID 149 and 174 is executed, right? Those values are compared with the manager ID column and the department ID columns of each row in the employees table. If the values match, the row is displayed in the output record of the employee ID with it. Yeah, I mean, I can go on and on around in circles with this, but basically you're just ensuring that like Diana had asked, you're pairing those specific columns. Yes, so you're actually giving that information so the system knows that this manager ID is in this department ID and that manager is this employee. So it's a trouble way to do this. So non-pairwise, and here, notice the difference here. We're using multiple columns in our select clause, but we're using multiple subqueries, and we have manager ID here, department ID here. So we're setting up kind of the same example, but we're ensuring that, this manager ID is comparing to see which employee is being managed by this manager in this department. Yeah, without me speaking too much, just take a look at this query and look at the results and make sure you understand what information you're getting out of this from department 80. So I do want to point out, as the description says, basically it's comparing the same idea, but one column at a time. Even though we have multiple columns in our select statement, the non-pairwise means that it'll basically compare them one at a time, which is not the most efficient, especially if you have several statements to compare. But if you see the way this is ordered, it should make a little more sense than my explanation. And you'll be able to run examples on these to become more familiar with the whole concept of pairwise. And please watch the videos. It'll help you understand how this works. And basically non-pairwise is writing one subquery per column. That's the difference. And here are the results of each of the subqueries. So this is returning department, this is returning manager ID, right? Manager ID, department. All right. Now that confused you quite handily with that whole pairwise, non-pairwise. Excuse me. Let's look at exists and non-exists, or not exists. Exists and its opposite, non-exists, are two clauses that can be used when testing for matches in subqueries. And it can be very helpful, especially if you have complicated queries. Exists tests for true or matching result. Excuse me. So to answer a question, which employees are not managers? You first have to ask who are managers. And then ask who does not exist in the managers list. So if you look at that logic, that's essentially what we're trying to accomplish. Of course, you can accomplish this many different ways, but we're running a select last name as not a manager from employees, and we're using an alias where not exists. Basically, it doesn't exist in this list. Select star from employees where manager ID is equal. So basically, we're saying these are all managers, right? And if they're not in this list of managers, then they're not a manager, which is what we have here. So we have 12 employees that are not managers. So you'd use a not exist here, and it would make that query actually actually makes a little bit more sense, right? Okay. So if you ran the same query using the not in, which you were introduced to before, yeah, and the same query, you would get different results because that will not work that way. The system does not, even though you think that that should work, that's a list, but it's not going to provide data because will not be in this list. So the logic is a little skewed because of how it works, because it looks for true and not true, and this is never going to be true. So that's just kind of an example how not exist will work. So, and all this is saying, and you can review this, basically if one of the roles, remember those null values, if one of them's not true, then it will return all are not true, because that's how you would use the in and then the not in, and that's why the whole idea of the not exist came around, to make that differentiation there. So, and there's where null can be a problem. So once again, beware of nulls and subqueries and using in and not in, because it will change the whole results. Always use a not exist if you're testing for values over a not in. That's the whole lesson here. And one last point. Some subqueries may return a single row or multiple rows depending on the data values in the row. If even the slightest possibility exists, and this will further answer Diana's question of earlier, if you're not sure, always run a multi-row subquery, and then you can change it afterwards. So select first name, last name, job ID from employees, where job ID is select job ID from employees, where last name is Ernst. So we're not sure if there's going to be more than one Ernst. So here, there's not a big deal because there's only one Ernst in the table. What happens if we hire Bruce's Ernst's wife, Susan, and we're trying to run a single row subquery, we'll get an error. So this was the kind of the last point. I knew I was going to get to that. So if in doubt, write a multi-row subquery. There you go, Diana. That's always your best bet. All right, exist, not exist, non-pairwise, multiple column subquery, pairwise, multiple column subquery. These are a little confusing. You will not have pairwise or non-pairwise on the final. So run through the examples, watch the videos. It'll probably make a little more sense, and then go from there. All right, hey, I got it right this time. Our last topic of the evening as far as module 9 is correlated subqueries. And the word correlated, yes, it means basically what you think it means. These queries are going to be correlated to each other. So identify when correlated subqueries are needed, construct and execute correlated subqueries, construct and execute name subqueries using the with clause. With clause, actually, I've done this quite a bit. Yeah. And you'll see how that works. All right, so sometimes you have to answer more than one question in one sentence. Your friend might ask you if you have enough money for a movie ticket, popcorn, and a drink. Before you answer the question, you need to know the price of the ticket and the popcorn, obviously. So you also need to know how much money you have in your pocket or your wallet or your purse. So actually, what seems like an easy question turns into a lot of questions. And that's usually the case. So in business, you might get asked to produce a report of all employees earning more than the average salary. We saw this before for the departments. So here, you first have to calculate the average salary per department, then compare the salary for each employee. The average salary, oh boy, it just goes on and on and on. So correlated subqueries, they're in Oracle. They perform correlated, you can perform correlated or queries that lead to other queries when you're using subquery from a specific column in the table. So here's kind of the order. You have basically a primary table or first table is usually referred to as the parent table. So get candidate row from your outer query, execute inner query using candidate row value, use values from your inner query to qualify or disqualify candidate row. And your nice little correlation here. So the correlated subquery is evaluated once for each row. So each row in the parent, that's processed in the parent statement. So get candidate row, execute, use. The parent statement can be select, update, so it can be any type of query. And so let's take a look at a correlated or correlated subqueries. So whose salary is higher than the average salary of their department? So to answer this question, we need to write a correlated subquery. The correlated subquery are used to by row to process each of the rows in your table. So alias here, and O for outer, I for inner. Select first name, last name, salary for employees where salary is greater than, select average group function from employees where I department is equal to. So basically, so we're looking to answer this question. And so we have correlated, a very simple correlated subquery, which is, it's just a very comprehensible way of understanding what's dependent upon what. And the reason why it's correlated, it has to process, it's essentially a single row being processed for the whole table, if it's applicable as far as the where clause. So it has to compare every employee, hence the correlation. So with the normal subquery, the inner select query runs first and executes once, returning values to be used by the outer query. That's a normal. With a correlated subquery, however, the query executes once for each row considered by the outer query. In other words, the inner query is driven by the outer query. So it just goes back and forth, a nice little circle. The correlated subquery in this example is this one here, which is, if you think about it, we want to evaluate all of the employees. And that's, so it's going to go through all 20 employees and make sure to return all the ones. So it's kind of like grouping, but the key here is that a correlated subquery is going to run for every row in your table to get the results. Any questions about correlated subqueries? Does a correlated subquery make sense to everyone? Thumbs up. Still processing, still processing. All right. All right, let's move on to one of our final topics, the with clause. If you have to write a very complex query with joins and aggregation group functions used many times, you can write the different parts of the statement as a query block. So now we're looking into kind of creating more efficiencies. So Oracle does allow you to write name queries, name subqueries in one single statement, as long as you start your statement with the keyword with. And I'll show you what I mean here in a second. The with clause retrieves the results of one or more query blocks and stores the results for the user who runs the query. So basically, it's like creating a routine in some manner of speaking. So the way you structure this, so it improves performance. You can, easy to read, and basically you don't have to rewrite the queries over and over. You just start with the keyword query, subquery name, so with, and give the subquery a name as, and then the actual query, and I'll show you what that looks like. And you can do that multiple times, and then you can actually use that subquery wherever you want to within your select statement by just simply calling it. So the way you do that, you write the query for the following, or an example, write the query for the following requirement, display a list of employees' last names that are not managers. We had this problem before. So to construct this, you need first to get a list of manager IDs from the employee table, right? Then return the names of the employees whose employee ID is not on the manager's list. So we can create, this is the same, remember there's several ways to to satisfy any of these requirements. And the width probably makes it much easier. So we can create a name subquery using the with clause to do this. So here's our the syntax. So we're calling this subquery for managers. We want to know all who the managers. So select distinct manager ID from employees where manager ID is not null. So we just created kind of a with clause subquery. So when we run this, because we have managers here, right? That's our name. So select last name as not managers from employees where employee ID is not in, and then running that little query right here, managers. So we get the same results that we got before, but that's a little simpler to read. So you run that, you run this, and you run that. Done. Does that make sense to everyone? If I inundated you all with so much information that so this is an easy way to put together a subquery so that you know that obviously you want to run this, and you just place managers right in there. So you have select the managers. All right, that's the with clause. Very fun to use. I recommend using it. I used it all the time. All right. So our terminology for our last topic is the with clause and the correlated subqueries. Remember, correlated subqueries, basically you need to know how you're going to evaluate whatever your result is. If you need to evaluate all the records in your table, then you write a correlated subquery as, and please go through the examples and the test queries so that you understand how that is different than your normal subquery. And you should have some intuition about that already. All right. Oh, someone writing in the chat. So Diana says, so for correlated subqueries, the subquery doesn't have to be independent anymore. That is the correct way to look at that. Absolutely. Diana, good interpretation. All right. So let me stop my PowerPoint and let's go to our module. We're in module 9, subqueries, right? I'll have the lecture here. There's some videos that will clarify or hopefully will not confuse you any more than I have. This one, I particularly watched these two because they explain the multiple role and the single role subqueries. And well, this one too. I mean, they do a pretty good job. But single role and multi-role, please enhance your resources. And then the operators for multi-role, any all, and see the difference there. And then the information that came right out of Oracle, if you want to review how this works with a simple example and what's being considered when you use an all is probably the biggest nightmare when it comes to making sure the results match what you're looking for. I saw this like 3 or 4 years ago. I thought this was visually helpful. So please review that. I'm not going to go through it now, but please review that. And I have it for any as well. And it's just a simple way of showing you what the result will be by running these particular multi-role comparisons in there. And it probably would make more sense. It did for me, so I thought this is a great way to illustrate that. Exists and non-exists is a little bit easier, but once again, pictorially or kind of an interesting way to look at exists and non-exists. So please go through those and make sure they make sense. What happens with the true and the false. And then I put in some advanced subqueries. Well, a little bit more advanced. Some that it'll extract and use some of the information that you've seen already and give you a better idea of how that works as far as subqueries. Subqueries are pretty easy to understand, but you can never have too much information on how to run them. Correlated subqueries. Once again, this will probably be the most confusing. This section that came out of Oracle or came from an Oracle vendor is another good way to. I pull a lot of the content from here, but it's another good way to read through this and go through some of the examples and watch a little video to help you truly understand what a correlated subquery is and how it's different than a regular subquery. So please do that. I do just click on the link. It should take you to that page, which is pretty new. I found that last year. All right, and then your practice, always helpful. I can tell that most of you are going through these anyway, these practice queries, because I can see that once again the result, at least you know essentially some of these aspects just by practicing and practicing. I do recommend that. So please go through as many of these as you can, and just remember you can copy and paste and try and recognize, the results and answer some of the questions. Always very helpful. So you not only have that, then you also have our practice assignments. Try it. And those backwards. So practice and solutions. Well, I really messed this module up, but I'll clean it up a little bit here. Practice and solutions for each of the topics. Always helpful, including a little, which I know that a lot of you have gone through this, because a lot of these questions, as you probably recognize on the midterm, came from these little exercises. Now, and there's queries in here that you need to read through and run through. And remember, this practice comes with the solutions, so more and more soaking in more and more information is always good. And with SQL, with SQL, the more you expose yourself to all the little aspects of it and anecdotes, then the more you can be comfortable with running any type of query. And I do want to remind you, you're learning the basic premise of SQL, and you'll be able to dissect and take in just about any level of SQL, which is really needed in our industry now. So practice, practice, practice. And then, yes, we go back into our general, kind of routine, at least for now. So one assignment is very similar than what you've done before. And I request, once again, download the document or copy paste the information from the document, write the queries, and make sure you run them in the SQL developer. And you can copy paste or screenshot or whatever into the document and submit it. This one, 8 questions. Fundamentals, single row, multi-row, done. All right. And then back to our little quizzes. All of the 3, well, only 3 of the topics. As I said, I'm not really focusing on correlated just single row, multi-row subqueries. I don't even think I have exist and non-exist in here, but that will be your exercises for module 9. All right. Any questions or comments, or I didn't even run any queries. Don't really stop sharing. All right. So there you go. You all recovered or made it through the midterm. You all did very well. I'm really happy. I don't know. Although there's quite a few of you that waited until yesterday. I was getting a little nervous, but you all did it, so I'm happy. Thank you. And you all did very well. So once again, be very proud of yourselves. There's not anything, I didn't see any major problems across the board with the midterm. So you must be learning something in this class, right? You're not losing all the information. So that's a good deal. So please continue to work hard. Oh, okay, Trevor. I'm glad you're feeling better now. And you did well. So thank you. Let's continue. Let's see. We will meet the Monday of Thanksgiving week in 3 weeks. So, and then the Monday after. But other than that, please continue to work hard. And remember these activities are due on Sunday. And so I will see you all next Monday, right?
Thank you. Bye.
Thank you. Take care.